Greetings! This recording covers the lesson on measures of central tendency. At the end of this lesson, you must have computed for the central tendency of the data. A measure of central tendency is also referred to as the central location or a measure of location. It refers to a value used to describe the center of a data set. Although there is a definition that states a single value that summarizes a set of data, but we are not going to consider it here since for mode there could be more than one value. There are many measures of central tendency, but this lesson will cover only four: arithmetic mean, weighted mean, median, and mode. Furthermore, we're going to limit our discussion on ungrouped data. Ungrouped is also referred to as raw, but we will refrain from using the word raw to avoid confusion from the meaning of data as raw facts that is used in computer studies. Oftentimes, measures of central tendency are referred to as average or typical. These are the other terms to consider while we are talking about a set of data. The main goal of quantitative research is to describe the characteristics of populations by determining the parameters. However, because of some constraints, data are collected from samples only, in which, with inferential statistics, we use these characteristics from sample to make educated guesses about population parameters. Parameter refers to a measurable characteristics of a population. The value is fixed, while statistic refers to a measurable characteristic of a sample. The value varies from sample to sample. The following are some symbols used in statistics. Sigma x means sum of the values. Sigma denotes summation, while x denotes a value. Capital letter N means population size, or total number of values or observations in a population. Small letter n means sample size, or total number of values or observations in a certain sample. Mu means population mean, while x bar means sample mean. The first measure of central tendency is the arithmetic mean. Arithmetic mean is the most widely reported measure of location. As a matter of fact, most people would refer to arithmetic mean when they use the word average. Arithmetic mean is computed by adding all the values and then divide the result by the total number of values. Population mean is denoted by mu equals the sum of the population values divided by the population size. The result is an example of a parameter. While the sample mean is denoted by x bar equals the sum of sample values divided by the sample size. The result is an example of a statistic. This is an example on computing for a population mean. There are 8 values, it means the population size is 8, and these values are 76, 82, 76, 85, 83, 83, 76, and 87. Their sum is 648. 648 divided by 8 is 81. The population mean is 81. This is an example on computing for a sample mean. There are 9 values. It means the sample size is 9, and the values are 5, 10, 8, 6, 8, 7, 9, 6, and 7. Their sum is 66. 66 divided by 9 is 7.33. The sample mean is 7.33. The arithmetic mean has the following characteristics. It is used with interval or ratio level of measurement. All the data values are used in the calculation. A certain set of data has only one mean. The sum of the deviations from the mean is always equal to 0. Please take note that the computed mean value may or may not be equal to a certain value in the data set. What's more, both the arithmetic and weighted, which will be discussed later, may not be appropriate to describe the average of a data set with extremely large or small values. For example, to describe the typical contract price of real estate properties with the following values of the inventory: 500,000 pesos, 600,000 pesos, 750,000 pesos, 750,000 pesos, and 5 million pesos. Obtaining the arithmetic mean of these 5 values generates an average contract price of 1,520,000 pesos, which is greatly affected by an extreme price that is 5 million, despite that the other 4 is below 1 million. Also, for grouped data with open-ended class such as above 50,000, arithmetic mean is not appropriate. Instead, median or mode would be a better option. The second one is the weighted mean. It is a special case of arithmetic mean. It is found by multiplying each observation by its corresponding weight. It is denoted by this expression. For example, in this data set, certain values appear more than once. The number of times they appear are the weights. There are 3 of 76, 1 of 82, 1 of 85, 2 of 83, and 1 of 87, while the size or the total number of values is 8. 3 times 76 plus 82 plus 85 plus 2 times 83 plus 87 is equal to 648. 648 divided by 8 is 81. Third is the median. A median is the value in the middle of a set of ordered data. For a data set with odd number of values, determining the median includes these steps. First, sort the values from smallest to largest. Second, identify the middle value. For example, to determine the median in this particular set of data, first, we need to sort the values. Then, find the middle value. The location of the middle value can be computed as number of observations plus 1 divided by 2. In this example, there are 7 values, so 7 plus 1 is equal to 8. 8 divided by 2 is 4. Count from 1 to 4 either side. The median is that value at the identified location. In this case, it is 82. For a set of data with even number of values, determining the median includes these steps. First, sort the values from smallest to largest. Second, find the arithmetic mean of the 2 middle values. This is an example. To determine the median in this particular set of data, first, we need to sort the values. Then, find the arithmetic mean of the 2 middle values. The median is located between these 2 values. Hence, the location of the middle value, which is computed as a number of observations plus 1 divided by 2, results to a fraction. In this example, there are 8 values. 8 plus 1 is equal to 9. 9 divided by 2 is 4.5. This denotes that we need to take the arithmetic mean of 4th and 5th values. Count from 1 to 5 either side. Take the mean of the 4th and the 5th values. The result is the median. In this case, the 2 middle values are 82 and 83. And their arithmetic mean is equal to 82.5. Median has the following characteristics. It is used with ordinal, interval, or ratio level of measurement. It is not influenced by extreme values. A set of data has only one median. Please take note that in a set of data with odd size, the median value is among the values. But for a dataset with even size, the median value may or may not be equal to a certain value in the dataset. Lastly, the mode. Mode refers to the value that occurs most often in a set of data. It can be used with a nominal level of measurement. A set of data can have more than one mode. In this dataset of grades in mathematics, the model grade is 76. It appears 3 times, while the other grade values appear either once or twice only. In this dataset of numbers of books owned, the modal values are 6 and 7, which both appear twice. Other values appear once only. This is an example of a bimodal dataset. In this dataset of civil status, the modal values are unmarried and married, which both appear 5 times, while widowed appears thrice and separated appears twice only. This is another example of a bimodal dataset. In this dataset of gender, the modal gender is male that appears 15 times, while female appears 9 times only. In this set of family size, each value appears once only. This is an example of dataset with no mode since none of the values appeared repeatedly. However, it could be argued that all values are mode because the most frequent appearance is only once, which is true to each of them. The same case may be true should each value appears twice or more. But personally, I would consider a dataset in which each value appears once as a set with no mode, while a dataset with each value appears twice or more as a multimodal set with all the values as mode. This is taking into consideration the meaning of the word often as many times. Once is just one time, while 2 or more is already considered many times. This marks the end of our lesson on measures of central tendency.